The world changed rapidly after the Second World War. Aviation was entering a new, exciting phase. Jet engines had proven their worth in military aircraft. They offered incredible speed and power. Engineers and visionaries began to dream bigger. They imagined passenger planes that could fly faster than sound. This was a bold ambition. It promised to shrink the globe. Journeys that took many hours could be completed in a fraction of the time. The allure of supersonic passenger travel was powerful. It represented progress and human ingenuity. Military jets were already breaking the sound barrier regularly. Pilots experienced the unique challenges and sensations of supersonic flight. This military experience provided valuable data. It showed that sustained flight at such speeds was possible. However, translating this to civilian transport was a monumental task. Passenger aircraft needed to be safe, reliable, and reasonably comfortable. They also needed to operate within the existing or slightly modified airport infrastructure. The technical hurdles were immense. Drag increased dramatically near the speed of sound. Frictional heat became a serious concern for the aircraft's structure. Engines would need to be extraordinarily powerful yet efficient. In the United Kingdom, serious studies began in the 1950s. The Supersonic Transport Aircraft Committee, STAC, was formed. It brought together experts to explore the feasibility of an SST. Maurian Morgan, a key figure at the Royal Aircraft Establishment, championed the idea of a slender delta-winged aircraft. Bristol Aeroplane Company also conducted significant research. Across the Channel, French engineers at Sud Aviation were pursuing similar goals. They too envisioned a sleek, fast aircraft. Both nations possessed strong aviation industries. They had the skills and the ambition to undertake such a complex project. These early research efforts laid the groundwork for what was to come. The dream of a supersonic transport was not just about speed, it was also about national prestige. In the midst of the Cold War, technological achievements were a powerful symbol. Successfully developing an SST would demonstrate a nation's scientific and engineering leadership. It would be a triumph of innovation. The United States and the Soviet Union also had their own SST programs. The race to build the first successful supersonic passenger jet was on. For Britain and France, it was an opportunity to assert their place on the world stage. The dream was bold, the stakes were high, the journey to create Concorde had begun. Developing a supersonic transport aircraft was an enormous undertaking. The research and development costs were staggering. No single European nation felt it could bear the financial burden alone. The technical risks were also substantial. Building an aircraft that could safely fly at twice the speed of sound required pushing the boundaries of known technology. It became clear that collaboration was the most viable path forward. Britain and France were both leaders in aviation. They had independently arrived at similar design concepts for an SST. A partnership seemed logical, combining their strengths and resources. This approach would pool talent and distribute the immense financial risk. Political motivations also played a significant role in fostering this collaboration. Britain, under Prime Minister Harold Macmillan, was seeking closer ties with continental Europe. Joining the European Economic Community was a key objective. A high-profile technological partnership with France could strengthen Britain's European credentials. For France, led by President Charles de Gaulle, the SST project was a matter of national pride and technological independence. De Gaulle envisioned France as a leader in aerospace. Collaborating with Britain offered a way to achieve this ambition on a grand scale. The project became a symbol of European capability. It was a statement to the world, particularly to the United States. The formal agreement to develop the SST jointly was signed in November 1962. It was a treaty, not just a commercial agreement, highlighting its political importance. The British Aircraft Corporation, BAC, and France's Sud Aviation were designated as the primary airframe manufacturers. For the equally critical engines, Britain's Rolls-Royce and France's Snecma were chosen to collaborate. They would develop the powerful Olympus 593 engines. The aircraft was to be named Concorde. The name itself, meaning agreement or harmony, reflected the spirit of the joint venture. This partnership was a landmark in industrial cooperation between the two nations. However, international collaboration on such a complex project was not without its difficulties. There were language barriers to overcome. Engineers and technicians from different countries had to find ways to communicate effectively. Different engineering philosophies and national standards sometimes led to disagreements. Even simple things like units of measurement, imperial versus metric, created complications. The initial designs from both countries had to be merged. This involved compromises and careful negotiation. Despite these challenges, the shared goal of creating a revolutionary aircraft provided a strong motivation to succeed. The Anglo-French Accord was a bold experiment in itself. The design of Concorde was revolutionary. Its most distinctive feature was the slender delta wing. This shape was crucial for efficient flight at supersonic speeds. It helped to minimize drag as the aircraft approached and exceeded Mach 1. The wing's leading edges were sharply swept back. This design also provided good lift at lower speeds during takeoff and landing, though it required a high angle of attack. The elegant curves were not just for aesthetics. They were a product of sophisticated aerodynamic calculations. Concorde's wing was a masterpiece of aerospace engineering, allowing it to slice through the air at unprecedented speeds for a passenger aircraft. Powering Concorde were 4 Rolls-Royce/Snecma Olympus 593 turbojet engines. These were among the most powerful pure jet engines ever developed for a civilian aircraft. Each engine could produce over 38,000 pounds of thrust with reheat. Reheat, also known as afterburners, involved injecting extra fuel into the engine's exhaust. This provided the necessary thrust surge for takeoff and for accelerating through the sound barrier. The engines were incredibly complex. They had to perform reliably across a vast range of altitudes and speeds. Their distinctive rectangular air intakes were also a marvel of engineering, adjusting their geometry to optimize airflow to the engines. Building an aircraft to withstand the rigors of supersonic flight required advanced materials. The airframe was primarily constructed from a special aluminum alloy known as AU2GN, RR58 in the UK. This alloy could tolerate the high temperatures generated by air friction at Mach 2. At this speed, the nose of the aircraft could reach temperatures of over 120 degrees Celsius. The aircraft also experienced significant thermal expansion during flight. It could stretch by as much as 30 centimeters. This had to be accounted for in the design. Another iconic feature was Concorde's droop nose. The nose section would be lowered during takeoff and landing to give the pilots a clear view of the runway. Concorde incorporated numerous complex systems. One critical system managed the aircraft's fuel. Fuel was pumped between different tanks during flight. This was done to shift the aircraft's center of gravity. As Concorde accelerated to supersonic speeds, its center of lift moved rearwards. Transferring fuel maintained balance and stability. The air intake system was also incredibly sophisticated. It featured movable ramps and spill doors. These adjusted automatically to slow down the incoming air to subsonic speeds before it reached the engine compressors. This ensured the engines operated efficiently, whether flying at Mach 2 or taxiing on the ground. Every aspect of Concorde was a testament to engineering brilliance. Concorde made its first test flight on March 2, 1969 from Toulouse, France. The British prototype followed a few weeks later. These flights were major milestones. They captured the imagination of people around the world. After years of development and testing, Concorde finally entered commercial service on January 21, 1976. British Airways flew from London to Bahrain. Air France flew from Paris to Rio de Janeiro via Dakar. These inaugural flights marked the dawn of a new era in air travel. Supersonic passenger flight was no longer a dream. It was a reality. The world seemed to become a smaller place. Concorde quickly became a symbol of exclusivity and glamour. Flying on Concorde was not just a journey, it was an event. It attracted a clientele of wealthy individuals, business executives and celebrities. Being a Concorde passenger was a statement. It signified success and a taste for the extraordinary. The aircraft itself was a flying icon, instantly recognizable with its sleek lines and distinctive silhouette. Its appearances at air shows drew huge crowds. The image of Concorde soaring through the sky became synonymous with technological advancement and human achievement. It was a source of immense pride for Britain and France. Inside, the cabin was relatively small compared to subsonic jumbo jets. It typically seated around 100 passengers in a single-class configuration. The seats were comfortable, though not overly spacious by today's first-class standards. What set the experience apart was the service and the sheer speed. Passengers were treated to gourmet meals and fine champagne. Attentive cabin crews catered to their every need. A prominent feature in the cabin was the machmeter. This digital display showed the aircraft's speed relative to the speed of sound. Passengers would watch with fascination as it ticked past Mach 1.0 and then climbed towards Mach 2.0. The primary routes for Concorde were the transatlantic crossings. British Airways flew between London Heathrow and New York JFK. Air France operated between Paris Charles de Gaulle and New York JFK. These routes were where Concorde's speed advantage was most pronounced. It could cross the Atlantic in under 3.5 hours. This was less than half the time taken by conventional subsonic jets. Business travelers could have breakfast in London or Paris, fly to New York for a lunchtime meeting, and theoretically return home the same day. This time, machine capability was Concorde's unique selling proposition during its golden age of operation. Section 5, A Symphony in the Sky, the unique Concorde experience. Flying on Concorde was unlike any other commercial aviation experience. The most striking sensation was the incredible speed. Passengers cruising at Mach 2, around 1,350 miles per hour, were traveling faster than a rifle bullet. At an altitude of nearly 60,000 feet or 18 kilometers, they were flying far above other air traffic and most weather systems. From this vantage point, the curvature of the Earth was visibly apparent. The sky above appeared a deep dark blue, almost black, a consequence of being so high in the atmosphere. It was a glimpse into the edge of space, a truly awe-inspiring view. The takeoff was a memorable event for anyone who experienced it. The 4 Olympus engines, with their afterburners engaged, produced a deafening roar and immense power. The acceleration was rapid and forceful, pressing passengers back into their seats. Concorde used a surprisingly short amount of runway before lifting off at a steep angle. This powerful ascent was necessary to climb quickly to its cruising altitude. The noise generated during takeoff was considerable, a factor that would later contribute to operational restrictions. But for those on board, it was the thrilling start to an extraordinary journey. The transition through the sound barrier, or Mach 1, was surprisingly smooth. There was no sudden jolt or boom felt inside the cabin, as some might have expected. Instead, passengers might notice a gentle nudge or a subtle change in the engine noise. The machmeter on the cabin wall would steadily climb, indicating the aircraft was now supersonic. As Concorde continued to accelerate towards Mach 2, a slight warmth could be felt on the cabin windows. This was due to the friction of the air molecules rushing past the aircraft's skin at such high speeds. The windows themselves were small, partly for structural reasons and partly due to the heat. Every aspect of the flight conveyed a sense of precision engineering. The aircraft felt incredibly stable and smooth at its cruising speed. Despite the immense power of the engines, the journey was remarkably serene once at altitude. The small cabin fostered a sense of intimacy and exclusivity. Passengers were aware they were part of a very select group. They were experiencing the pinnacle of air travel technology. The Concorde experience was a symphony of speed, sound, and sensation. It left an indelible mark on all who flew on her. It was truly a unique way to travel the world. Section 6, Headwinds and Hurdles, Operational Realities. Despite its technological brilliance, Concorde faced significant operational challenges from the outset. The most prominent issue was the sonic boom. When an aircraft flies faster than sound, it creates shock waves that travel to the ground, producing a loud, startling noise like thunder. This sonic boom was a major concern for populations living under potential supersonic flight paths. As a result, many countries banned Concorde from flying supersonically over their land territories. This severely limited the number of viable routes. Transoceanic routes like the North Atlantic became its primary domain, where booms would occur over water. Concorde's operating costs were exceptionally high. The 4 Olympus 593 engines were incredibly thirsty for fuel. Fuel consumption per passenger was significantly higher than for subsonic jumbo jets like the Boeing 747. This was particularly true during takeoff, climb, and any subsonic portions of a flight. While designed for speed, Concorde was not fuel efficient by conventional standards. The high fuel burn, combined with the small passenger capacity, meant that ticket prices had to be very expensive to even approach profitability. This restricted its appeal to a niche market of wealthy individuals and business travelers. Noise pollution around airports was another persistent problem. Concorde's powerful engines made it one of the loudest commercial aircraft ever built, especially during takeoff and landing. Its noise footprint exceeded the limits set by many airports. This led to operational restrictions, such as curfews on nighttime flights. Some airports were reluctant to grant Concorde landing rights at all due to noise concerns. Community opposition in areas near airports was often strong. British Airways and Air France had to carefully manage flight schedules and procedures to minimize noise disruption, adding another layer of complexity to its operations. The aircraft's small passenger capacity, typically around 100 seats, also posed an economic challenge. Subsonic wide-body jets could carry 3 to 4 times as many passengers. This meant that Concorde could not benefit from the same economies of scale. Each flight had high fixed costs, which had to be spread over a small number of paying customers. Furthermore, Concorde was a highly specialized aircraft. It required dedicated maintenance crews and facilities. Spare parts were unique and expensive. The complexity of its systems meant that maintenance turnaround times could be longer, impacting aircraft utilization. These operational realities made Concorde a demanding aircraft to operate. Section 7. Economic turbulence, the cost of speed. In the early days of the Concorde program, there was great optimism about its sales prospects. The manufacturers anticipated orders for hundreds of aircraft. Many of the world's leading airlines, including Pan Am, TWA, Qantas and Japan Airlines, placed options to purchase Concordes. They were eager to be part of the supersonic future. The sleek model aircraft displayed in airline offices symbolized a new age of rapid global travel. This initial enthusiasm, however, proved to be short-lived. The economic landscape of aviation was about to change dramatically, and with it, Concorde's commercial fortunes. The 1973 oil crisis delivered a severe blow to Concorde's economic viability. The Organization of Arab Petroleum Exporting Countries, or OAPEC, proclaimed an oil embargo. The price of crude oil quadrupled in a matter of months. This had a devastating impact on the airline industry worldwide. For Concorde, with its high fuel consumption, the effect was particularly acute. The projected operating costs, already high, skyrocketed. Airlines began to reconsider their commitments to supersonic travel. The focus shifted from speed to fuel efficiency and cost reduction. The era of cheap oil, which had partly fueled the supersonic dream, was over. Faced with soaring fuel prices and concerns about profitability, most airlines cancelled their Concorde options. One by one, the orders evaporated. The dream of a large global fleet of Concordes began to fade. In the end, only the state-owned airlines of the manufacturing countries, British Airways and Air France, took delivery of the aircraft. A total of 20 Concordes were built, including prototypes and development aircraft. 14 of these entered commercial service, 7 with British Airways and 7 with Air France. The massive development costs, estimated to be over £1 billion at the time, were largely absorbed by the British and French taxpayers. The aircraft were essentially sold to British Airways and Air France at a nominal price. The governments hoped that the airlines could operate them profitably, or at least break even. For many years, Concorde struggled to achieve consistent profitability, even with premium ticket prices. Its operation was often subsidized, directly or indirectly. While it offered unparalleled speed and prestige, the economic model was always challenging. The high cost of speed, exacerbated by the oil crisis and operational limitations, meant that Concorde remained a magnificent but commercially constrained marvel. It was a triumph of engineering, but a difficult business proposition. Section 8, the final descent, grounding an icon. For over 2 decades, Concorde operated with an impeccable safety record. It was a testament to its robust design and meticulous maintenance. However, this changed tragically on July 25, 2000. Air France Flight 4590, en route from Paris to New York, crashed shortly after takeoff from Charles de Gaulle Airport. The aircraft, fully laden with fuel and passengers, erupted in flames and crashed into a hotel in Gonesse. All 100 passengers and 9 crew members on board were killed. along with 4 people on the ground. The accident sent shockwaves through the aviation world and marked the beginning of the end for Concorde. The official investigation by the French Accident Investigation Bureau, the BEA, revealed a chain of unfortunate events. A metal strip, later identified as debris from a Continental Airlines DC-10 that had taken off minutes earlier, was left on the runway. As the Concorde accelerated for takeoff, one of its tires struck this debris. The tire burst and a large piece of rubber was flung upwards. This fragment struck the underside of the wing with immense force, rupturing one of the fuel tanks. Leaking fuel ignited, likely from an electrical spark or contact with hot engine parts, leading to a catastrophic fire and loss of engine power. In the aftermath of the crash, both British Airways and Air France grounded their Concorde fleets. An intensive program of modifications was undertaken to improve safety. The fuel tanks were fitted with Kevlar linings to prevent punctures. Specially developed, more resistant Michelin tires were installed. The wiring in the undercarriage bays was also better protected. These modifications were designed to prevent a recurrence of the specific circumstances that led to the Paris tragedy. After extensive testing and regulatory approval, Concorde was cleared to return to service in November 2001, more than a year after the crash. Despite the safety modifications and a brief, optimistic return to passenger flights, Concorde's days were numbered. The global aviation industry was hit hard by the economic downturn following the September 11, 2001 terrorist attacks. Passenger numbers on premium services like Concorde declined. Furthermore, the Concorde fleet was aging. Maintenance costs were steadily rising. Airbus, the successor company to Aerospatiale, formerly Sud Aviation, announced that it would no longer provide crucial support and spare parts for Concorde beyond 2003. Faced with these mounting challenges, British Airways and Air France jointly announced in April 2003 that Concorde would be retired from service later that year. The supersonic era was drawing to a close. Section 9. Echoes of a supersonic past. Concorde's enduring legacy. Concorde remains an undisputed technological masterpiece. It was a machine that pushed the boundaries of what was thought possible in aerospace engineering. From its slender delta wing and powerful Olympus engines to its advanced materials and complex control systems, Concorde was at the cutting edge of aviation technology for its time. It demonstrated that sustained supersonic passenger flight was achievable. The engineers and designers who created Concorde overcame immense challenges. Their ingenuity and dedication resulted in an aircraft that was not only incredibly fast, but also remarkably beautiful. It set a benchmark for aeronautical innovation. Concorde was more than just an airplane, it was a cultural icon. It symbolized an era of great ambition and optimism in technology and travel. For nearly 3 decades, it represented the ultimate in speed, luxury, and exclusivity. Its sleek, futuristic shape captured the public imagination like no other aircraft. Concorde appeared in movies, advertisements, and art, becoming a globally recognized symbol of the 20th century. It evoked a sense of wonder and pride, particularly in Britain and France. Even today, years after its retirement, the name Concorde conjures images of grace, power, and a bygone era of glamorous air travel. The Concorde program also provided valuable lessons for future aerospace endeavors. While a technical triumph, it highlighted the significant economic and environmental challenges associated with supersonic transport. The issues of high operating costs, sonic booms, noise pollution, and fuel efficiency remain critical hurdles for any new SST project. The experience with Concorde has informed the development of next-generation supersonic aircraft concepts. Researchers are now focusing on designs that are quieter, more fuel-efficient, and environmentally sustainable. The legacy of Concorde includes not only its successes, but also the hard-won understanding of the complexities involved in making supersonic travel mainstream. The fascination with Concorde endures. The surviving aircraft are now prized exhibits in aviation museums around the world. They attract thousands of visitors eager to see this legendary machine up close. These preserved Concordes stand as silent witnesses to a remarkable chapter in aviation history. The dream of routine, affordable supersonic passenger travel remains largely unfulfilled. However, Concorde proved that humans could conquer the sound barrier for civilian purposes. It continues to inspire new generations of engineers, designers, and aviators. The echoes of its powerful engines and its sleek silhouette against the sky remind us of a time when the future of air travel seemed to be twice the speed of sound.